Welcome back, scientists. Today, Kim is investigating one of the most important ideas in physics, light. You already know that we need light to see. But in year 6, we go deeper. We'll explore how light travels, how mirrors reflect light, why shadows form, how we see objects, and how devices like periscopes use reflection. By the end, you'll be able to explain light like a real scientist.
The first big idea is this: light travels in straight lines. To test this, Kim shines a torch through holes in 3 screens. When the holes are lined up, the light travels straight through and reaches the target lamps. But when one screen moves out of line, the light is blocked. This shows us that light does not bend around the screen. It travels in a straight path. A torch beam travels in a straight direction. A laser pointer also shows a very clear straight path of light.
So, how do we actually see? We see because light enters our eyes. But for most objects, the object does not make its own light. This toy rocket is not a light source. A lamp shines light onto the rocket. The light bounces or reflects from the rocket into Kim's eyes. That is how Kim can see it. The correct order is light forms from a sort. If travel light reaches the object or no reflected light reaches our eyes, we cannot see it clearly.
Sometimes people think our eyes send out light. But that is not how seeing works. Our eyes receive light. They do not shine light onto objects. You can see a book because light reflects from the book into your eyes. You can see the moon because sunlight reflects from the moon into our eyes. You can see your friend because light reflects from them into your eyes.
When light bounces off a surface, we call it reflection. Mirrors are very good reflectors because they are smooth and shiny. When a ray of light hits a mirror, it reflects in a predictable direction. The incoming ray and the reflected ray make massive grains. This is why mirrors can form clear images. A calm lake can reflect mountains because its surface is smooth. A spoon can reflect your face, but the reflection may look stretched or curved.
Reflection is not just interesting, it is useful. A periscope uses mirrors to help someone see around or over an obstacle. Inside a simple periscope are 2 mirrors. Light from the object enters the top of periscope. It reflects from the first mirror, travels down the tube, reflects from the second mirror, and then enters the eye. Submarines use periscopes to see above the water. They show that light changes direction when it reflects from mirrors. Shadows also prove that light travels in straight lines. A shadow forms when an object blocks light. Here, the torch sends light towards the wall. The ball blocks some of the light rays seen. The part of the wall behind the ball receives less light, so it looks dark. A shadow is not an object. It is an area where light has been blocked. The shape of the shadow depends on the shape of the object blocking the light. The size of a shadow can change.
Let's see what happens when the teddy bear is closer to the light. It blocks more light, making the shadow larger. Now, closer to the screen, the shadow is smaller and clear. Your shadow can look long in the evening because the sun is low in the sky. And a hand puppet makes a shadow because your hand blocks light.
Different materials affect light in different ways. A transparent material lets most light pass through clearly. Glass is transparent, so we can see through windows. A translucent material lets some light through, but scatters it. Frosted plastic or thin paper can be translucent. An opaque material blocks light. Cardboard, wood, and metal are opaque. A window is transparent. A bathroom privacy screen is often translucent. The sun is our most important natural light source, but it is also extremely powerful. You should never look directly at the sun. Strong sunlight can damage your eyes. Even during special events, such as an eclipse, you must use proper safety equipment. You can protect your eyes by wearing sunglasses, using shade on particle, and wearing a hat on bright days. Light helps us see, but very bright light can be dangerous to our eyes.
Let's check what you've learned. Question 1. How does light travel? Light travels in straight lines. Question 2. How do we see an object that is not a light source? Light reflects from the object into our eyes. What type of surface gives the clearest reflection? A smooth, shiny surface like a mirror.
Today, Kim discovered that light travels in straight lines. We see when light enters our eyes. Mirrors reflect light clearly. Periscopes use reflection. Shadows form when light is blocked. And bright light from the sun must be treated safely. Great work, scientist. Keep looking carefully, questioning deeply, and thinking like a physicist.